tilt the camera over a little further so you can see more of the machines. Exciting, I guess. Alright, what this video is about, I guess you can probably tell from the title what it is, but first, I thought this was really cool. I got an email, private email from someone here and saying, "Dave, I have been following your videos for several weeks now and want to thank you for straightforward reviews and advice you give concerning machining. I have purchased a 7x10 Harbor Freight lathe and have been trying to educate myself on the correct way of setting it up and operating it. I have really used your content as a valuable resource." And then he goes on to say that he had bought a tachometer that I showed in a video a long time ago and connected it up or whatever. Then he goes, "On a side note, I am also looking forward to seeing your review on the new bandsaw. I purchased the 8-inch Delta bench grinder after I saw your review and agree with you. For the money, it's probably the best bang for the price." So I thought that was really cool. But on the subject of comments, things like this, this video is a result of 2 comments that were left on other videos. One comment was, "Dave, why don't you try Anchorlube?" Never heard of it. Okay. The other comment was talking about cutting fluids and saying, if you think about it, when your insert is doing cutting, the cutting fluid is on the outside. It never really gets to the tip of the cutting tool or the side when you're moving sideways or whatever, turning. So I went to Anchorlube's website, filled in their form requesting a sample, and they emailed me back saying, "We sent you a sample here and we can't wait to see your review on it." So okay, I'm in the fire now. They sent me a sample and they want to see the review on it. So what do? I'm going to do like everybody else. I mean, Randy Richard went above and beyond the call of duty. If you go and find his review on Anchorlube, his bottom line was it wasn't bad, it wasn't good. I mean, he was completely neutral on the subject, so I've got to do the same thing. So I was thinking, alright, I'm probably going to just copy everybody else in how they reviewed cutting fluids and whatever, all the different stuff out there, and see which one's better. So the first thing I did was I taped what I have. Alright, this is going to be a real difficult video to do. I'm basically here just showing what I've found or used here over time. A lot of this was purchased way back when I first started. No clue what I was doing, so it's a learning curve. I'm just buying some stuff here, stuff I had to do tapping and turning and milling. But over time, you know, this is difficult because there's a lot of stuff out there. I mean, the commercial websites, you see, what is it? There's coolant, cutting fluid, and lubricant. So as far as coolants, I think that's all those different coolants that they have are more for CNC machines. Full-on automation where a cutter's doing a bazillion RPM, cutting steel at 10 feet per second. So on a mini lathe in a mini mill, I don't think coolant's necessary. I think I heard somebody did do it on a mill, because when I did the video converting the rubber waffle things, the chip guards, over to leather, I remember being asked, does the leather hold up to different chemicals and coolants and so I guess you can go and buy the tray that goes underneath the water heater, the big round overflow tray, and stick the mill in the middle of that and do some kind of coolant system. But I don't know how the ways and the machine's going to take it, and most of the coolants I see too, you know, you're going to buy 1 gallon or a 5-gallon container of it. It's a lot of money. So I kind of rule out coolants, which leads me down to now lubricant and cutting fluids. But over time, all the different videos that I've just stumbled across and comments that I've received, both in the videos and privately, are all kinds of things. One of the key ones, though, for cutting is a mixture of WD-40 and kerosene. And what I found really interesting is I know two professional machinists, and they always, both of them say their secret is kerosene. Secret that they don't want to let out, but they let out. I've never tried kerosene. I wish I could. I keep trying to find a nice little quart, one of these tight containers of it, but I haven't been able to find one yet to try it. I have tried a lot of different things I thought was equivalent. There's alcohol, there's MEK, acetone, everything that I had, and I didn't really see anything wonderful, but they say WD-40 and a kerosene works great on aluminum. I've seen another guy swear that butter is the best thing to use on brass. I've seen people use margarine, lard, peanut oil. I saw a couple of places saying diesel, so I wound up finally getting diesel, but I haven't had the chance to try it yet. Dish soap, which this is a new addition to the shop here that I'll get into. I think this is dish soap somehow. Somebody said that. It's lava soap or something like that. A lot of different things. There's people that say Cool Cut paste wax is best on aluminum. Of course, motor oil, which I use, and there's a lot of places that use old motor oil, used motor oil. Seen chainsaw oil, water-soluble oil, which I have back here. Lots of different stuff. Crisco, it never ends. Condensed milk is the best thing to use on copper. But if I just want to cover this area, which is threading and tapping, just making threads, this was something I just had. I used it. It was my dad's, and they used it professionally on job sites to do all their large tapping and threading and stuff. I don't see anything that great about it. It's still a liquid. It's pretty much so like the COC 36. And this guy I just bought off of Amazon because, again, this was way back in the beginning. So I just bought an assortment of stuff to see what it would do, and this is so watery. I do use this for drilling. No, I haven't used it for boring. Just mainly drilling to use it up and get rid of it. My dad, though, did use Rapid Tap. I guess that's what they had on the job sites, and I'm almost done with it, so that'll be the end of that. Magic Tap definitely is my favorite. The forces used to either tap or thread with a die are significantly reduced with this stuff. The quality of the threads, looking at the surface of it under a 10x loop, eye loop, beautiful, beautiful job. I did use this yesterday to do threading. I was making those 4 tool holders for the A to Z tool post, and I decided to use this on one. Now, using this, I can't get the tap completely through the top. I go in so far, and it starts getting really tough, so you gotta back it out, clear all the chips out of the tap, and then finish tapping the hole. With this stuff, I was able to go completely through, less force, so it was really nice. But afterwards, comparing the threaded holes with this, with Tap Magic, and with the Anchorlube, Tap Magic threads were significantly nicer looking. So, Anchorlube's nice, but I'm going to stick with Tap Magic. Now, when it comes down to cutting, what did they say? I mean, the definition of any substance applied to the cutting zone is called cutting fluid. So you can say lubricants or cutting fluid, it's all cutting fluid. Everybody's seen me use this. I think that's what the professionals are using. Adam Booth, Tom Lipton, and so on. Whenever you see them drill or something, it looks like they're applying plain motor oil. Tom Lipton did mention, he did a comparison, show and tell, on different cutting fluids. And he did mention soluble oil, and it was interesting to me is, how do you get oil to mix with water? But this stuff does. The other interesting thing is if you go to like CNC tool suppliers, they're all recommending the use of soluble oil. And also the coolants, I had here soluble oil, and this is settled down, but when you mix it up, it turns white, and it looks just like, and acts just like the coolant that they have pumping all over the place. So I need to play with soluble oil more, because I think that is probably the correct thing to use, even over motor oil. But like I said, I haven't had a chance to use that. I've used WD-40, I've used a bunch of other stuff, don't really see any kind of magic. Saw this on Grizzly, and I guess somebody else asked me, where did you get it? Because they couldn't find another source for it. They used theirs up. I saw it said for aluminum, all the work I was going to do, or primarily the work I'm going to do, is on aluminum. So I picked this up, and I use this especially when I'm using the parting tool. It works great, I get great finishes, and on boring on the mini lathe, I cannot bore without some kind of cutting oil, fluid, anything in there. Usually I use the A9 because I'm only bored so far with aluminum. I haven't done any steel yet. It's a dream. So I would recommend that. And like I said, I want to play with the soluble oil more and see what I get for finishes. So, and I probably will continue using motor oil. So my opinion is, if you want to drill, turn, bore, this, that, use whatever you want, because this list is huge and they all swear by something different. So if you guys want to get some lard, margarine, butter, diesel, dish soap, cool cut, paste, wax, whatever, everything works on everything, and it's fantastic. So I hope this helped out. This is just what I've started with, and I haven't really dove or seriously thought about, done tests or compared all kinds of different things like this and what comments people have left. Alright, so I've got that done now. Now, what am I going to do next? But you think about it, I mean, it's really interesting, all of the different recommendations there are as to what cuts best. People are out there comparing stuff, one versus the other. And it's kind of funny, somebody said, hey, let me go rob the kitchen, get a stick of butter and try that and see how it turns. Like, okay. But on the Anchorlube, I did go back this morning and re-looked at the three tool holders are now completely scrambled up because I've been moving them all over, so I don't know which one's which. And I went back and looked at all the threads underneath the magnifying glass, knowing that 3 holes in a row were Anchorlube and 1 hole on the right side was done with Tap Magic. And I could not identify which tool holder was done with the Anchorlube. So, I mean, I really looked and I couldn't tell the difference. So I have no idea when I did it why I said some threads were dirty or didn't look good. So there's one plus for Anchorlube: reduced friction during tapping. That was amazing. So to move on, what am I going to do next? Well, I'm going to do what everybody else does. I'm going to compare it on the lathe and turn different surfaces, two different types of material, aluminum and 1018, and compare finishes. Alright, I hope this is a good angle. I played with a lot of lighting and a lot of different things. the best place for it is right where I need to be to machine. So zoomed in, I'm going to do a test here with raw A9 and Anchorlube on aluminum, and then I'm going to do a test on 1018 with raw motor oil and Anchorlube. Hopefully you guys can see the finish on it. I'm not going to use any fancy tools like my great aluminum TGMT inserts. This is just a plain old TCMT, I think, or something insert. So let's see what it does. Hopefully the grain, you can see it's kind of nasty right now, and I may get in the way here to be able to do this machining. And I'll pull stuff back, but yeah, this is definitely in my way. Alright, well, I'll scrunch around the camera here. Alright, let's see here. I need more than that. I'll do a 4/1000th cut. Oh, this is nice without a round, huh? So here's the raw. I'll do another 4/1000th cut. And then stop it so you can see it. Let's see. 1, 2, 3, 4/1000ths right there. I don't look too bad from where I'm at, but especially using this tool. Alright, so there's, let me shut it down. Boy, that's a pretty nice finish. Wow, alright. So now I need to do the same thing with A9. Let's see if there's any difference. In my opinion, that's pretty nice right now. Alright, it's covered with A9. Coming on the 4/1000ths. 1, 2, 3, 4. The chips coming off of the curl, as you notice, are longer. Let me try to clean that off. There. Set it down, and what does that look like to me? That is slightly nicer. Slightly nicer. Okay, so let's do it with the Anchorlube. And the one comment, oh, I just dropped the lid. One comment I'll make is Anchorlube dries really fast. So it's definitely water, but for some reason it dries incredibly fast. So there's some Anchorlube on it. And another 4/1000ths cut. Let's see if it makes any difference, huh? 1, 2, 3, 4. Chips are staying long, just like with the A9. Clean it off again. And looking at that, that is not a great finish. It's left black in there somehow. Yeah, there's definitely black in there. I don't know if you guys can see it. I hope so. But that's... okay, that loses. I'm surprised. Because Randy Richards was saying he found no difference in any... come on, out of there. There we go. There's definitely something black in that. Okay, so let's try 1018. I'll do way back in here. Piece of 1018. Raw motor oil and Anchorlube. So bring this in. Bring it out. Yeah, I should go on the larger surface. Alright, lock it down. So this will be raw. Swing around this side of the camera and see if I can try to see where I am. 4/1000ths cut. Long tip. Yeah, it's doing its classic bouncing, it's cutting, and it's not cutting. So that's typically what I do get on 1018. Oy. So let's try motor oil here and see what happens. Again, the best thing for 1018 is just high-speed steel, not a carbide. Alright, that was just regular motor oil. Go in another 4 thousandths, 1, 2, 3, 4, and cut away. Same kind of mess here. So, no real, wow. It actually almost seems like that was worse. Where's the paper towel? Yep, that's worse. So it's kind of a crapshoot, but alright, well, let's try the Anchorlube and see what happens. Go in another 4. 1, 2, 3, 4. Same mess. It cuts, then it doesn't cut, then it cuts. Clean that up. Yeah. Not good. So I don't see any great advantage to using that stuff. But where is high-speed steel cutter? Not that one. Is this one set? Yeah. Big difference when you use high-speed steel on stuff here. So that's kind of my comparison test. I don't really see that great of stuff on it, but ow, loosen that up, swing it around. Alright, lock it down there. And just for grins, I will use the motor oil on it. But you do need some kind of a lubricant or cutting fluid. And go in there with this guy here. Probably at the wrong angle, but let's see what happens. Big difference as to how it works. That's pretty clean looking, huh? Clean that off. Yeah, still have oil all over it. I'll get this out of the way before I get my fingers snagged in there. There. Yeah, not the greatest finish. That angle cutter they showed in the last video is like the best thing there is for finishes. But so I hope that helped out. I do see so far a difference using the Anchorlube, so I'm not sure how to review it. Alright. Well, there's the comparison. Which one's better, the same, or worse? So, one thing hit me in that video, though, reviewing the film, tape, whatever you want to call it, was the one comment that was left saying that cutting fluid never gets to the tip of a tool. If you notice in the video, when I'm done turning each finish with different things, I'm wiping fluid off of the surface that was just turned. So if cutting fluid never touches the tip, how is it that oil or whatever is left on the surface that was just turned? That should be absolutely clean. There is nothing I can find on YouTube or any place that explains how cutting fluid, any kind of fluid, gets to the tip of a tool, and yet there is a film of material left after I turned it. That should have been absolutely spotless. So the next kind of little piece I shot was just what I could find in it that I found interesting on YouTube about where cutting oil is and this subject. Yeah, this is the piece of video that I was looking for. Managed to find it, and you'll see in theory the cutting fluid is up here, and your cutter of course is digging in, so the cutting fluid never touches the surface to protect it. But it was interesting just watching this thing, because watch the junk here. You can see, look at it, tears here, and you'll see this eventually go down below. There it goes, blob. So I don't know how they're recording this, what the material is, how they've got this angle. There they are, there's more junk building up in there. and you can kind of see the surface looks pretty good, but then there's a big mess in there. So I don't know with the speed how much distance that is. But the curious thing too is you look at, I don't know what material this is, but you look at this, my chips don't look like that. They're coming off nice and clean and curled and so on. I've looked at them under the 10X and they don't look anywhere as like this. So, but I can again say cutting fluid somehow makes a difference. I know it keeps the tool cool because there is some cutting fluid getting someplace on the tool to take the heat away from it, so it is going to prolong tool life, and it definitely makes a difference when I'm boring. I cannot bore without cutting fluid, anything. If I'm on aluminum, I'm usually using A9. Steel is always motor oil. I've used motor oil too on aluminum and had excellent results. So, and since I realized that I had a great camera angle looking at the videos, it was showing everything, I took the opportunity to just simply share some other turning and tools. Alright, I just reviewed the footage and it looks like this lighting and the camera angle happened to be really good, so I wanted to show you what my favorite Cobra carbide insert does on aluminum here without anything. I don't think I've ever used them. I mean, I gotta learn to keep my hands out of the way, so I hope this camera's focused right now. Alright, come in just a few thousand. But there's the finish with the Cobra carbide. Okay, going backwards looks like I messed it up. Usually I'll do a finish and then I'll just pull it out and say done. That was like a half a thou cut. Turn it off and see what it looks like. Yeah, not too bad. No, not too bad. I like it. So you can scotch brite that or do anything left. But I like the finish on it. So I just wanted to come back and share that. Yeah, again, since I've got a really good lighting, I said I wanted to mess with the soluble oil here. So here is a high-speed steel cutter, and I'm going to use motor oil, clean it off, and then the water soluble stuff. So remember, keep my hand out of there. Where it is, another paper towel. Hopefully it's still in focus. Where am I? I need to go. Yeah, that'll work. So there's motor oil, 1019. 2000s. Oh, that's not that much. I need to go in further. That means I need to put motor oil on it again. So behind the camera, there we go. Motor oil, 4/1000 cut. 1, 2, 3, 4. Does not look that hot. Alright, shut it down. Clean it off. No, it didn't look too bad once you clean it off. Alright, so what does that look like to me? Yeah. Not that great. So let's try the soluble stuff. Sneak around behind the camera here. Shake this up. Alright, bringing up the speed. Going 4,000. Same cut. Seems to be cutting differently. Clean that off. That seems like that made a difference, guys. You look at it. Yeah. Hard to say. I don't know what that black... Is it smooth? No, it's rough. Might be the cutter. Might be the cutter. Let me try. Alright, I guess I'll try just the generic cutter. Same one that I did earlier. See what it does. Angle it a little bit, bring it in. Yeah, that should be fine. Alright, motor oil again. Alright, up with speed. Motor oil on there. Back it up. Come on in and touch it. It's cut. A lot of smoke coming off of it. Man, it sounded like it was more grinding than cutting. What does that look like to me? It's a mess. Okay. Try some water soluble here. Just hard stuff. Come on, why aren't you coming out? There it is. Bring it up to speed. You take it in. Does it make a difference? No, I don't think so. As always, I can hear it cut, and then it doesn't cut. What does that look like to me? A little bit better, but not the greatest. So, alright, well, I don't see much of a difference on steel with water soluble versus regular motor oil. And for what it's worth, I did copy Randy Richards' test method that he used to check friction on Anchorlube versus other cutting fluids, where he used current. And I'm thinking his lathe is probably 220 volts and a heavy duty motor, and power is current times voltage, so I'm at 110. So I'm figuring, you know, if you do like say 10 watts at 220, it's what's 0.4, 40 milliamps. At 110 it's 80 milliamps. So you're going to see a lot more change in the forces of the motor, whatever you want to call it. So I did run the test, the same thing as he did. I ran it on aluminum and I ran it on steel, and I wound up with the exact same results. No change on aluminum using Bare versus A9 versus Anchorlube. And on 1018, same thing. I ran it Bare, looking at the current. I used oil rather than A9, and then I used Anchorlube, and I got the same current reading. So the only thing I can tell you is that the friction on steel is a lot higher than it is on aluminum, which is probably a no-brainer. There was a lot more current. It was pulling about an amp more turning steel. So that's the results of that test. And now for the conclusion to all of these tests, what I finally realized. Now I know what I'm about to say is probably going to upset a lot of people. A lot of people are going to disagree with it, but this is just kind of my thoughts on what happened or what I've realized here. Now, if you're searching for that video that's going to show you which one is the best cutting fluid, lubricant, you're not going to find it, because everybody has a different opinion. In my opinion is it's all about which cutting tool you use. You use the right cutting tool for the material that you're turning and you're going to get a nice finish. You use the wrong tool and you're not going to get a good finish. It doesn't matter what fluid you're using. Now some fluids may do slightly better than others, but to compare them to one another, I don't think is just, or whatever you want to call it. What you do is you test the fluid for what it's advertised to be. If it's a lubricant, is it lubricate? Does this fluid lubricate better than this fluid? That would be apples to apples, not testing different lubricants for a better finish, because they're not designed for that. Anchorlube was not advertised as a better lubricant, a better finish. It was advertised as an environmentally safe product. So if you want to test it for that versus something else that's advertised as environmentally safe, now you're doing apples to apples. Is it environmentally safe? I don't know. I'm not going to drink it, and I'm not going to pour it in a tide pool to see what dies. But in comparing, a lot of people are comparing this lubricant to this one to get a better finish. My opinion is somehow bias gets into the picture. And it would be, I think, you know, this guy says this is better on aluminum, this guy says this is better on aluminum, and I have a feeling he's testing it with this tool and he's getting a better finish with this tool. He's testing it with that tool, and so this is giving him a better finish with that tool. So just like bias somehow entered in with the Anchorlube when I did the tapping, I went first time looking at it, looking at the thread, saying yuck, went back the next day, and I cannot tell you which one was tapped with the Anchorlube. So if you're looking for different fluids for whatever function, just pick one, because I think they're all pretty much the same. Anchorlube is advertised as an environmentally safe product. Is it? Probably yes. They're advertising it at that. If you're in a large machine shop where you have 5 or more guys turning or machining at the same time using a petroleum-based product, you're going to have smoke in that shop. So testing the Anchorlube on that basis, you don't get smoke, you don't smell anything. And if you think about it, when you smell something, it's because molecules of an item, a particular substance, molecules are escaping from the surface of it, and they're floating in the air. They enter your nose, and you're smelling it. It's also entering your lungs. So I don't know how lungs manage to survive this environment. You're breathing in dust, pollutants, carbon monoxide when you're in a traffic jam, and so on. So I'm sure if you're in a large machine shop, I would rather be using Anchorlube than any petroleum-based product. Does it work? Yeah, I don't really see any differences in comparing them, which, like I said, is unfair. But so I hope I haven't upset too many people. I hope I've contributed something in this video, and I'll see you next time.